Hello and welcome back to CS 128 Honors. Today we'll be covering Structs Part 2. Alright, let's get started. So, specifically, today we'll be covering struct methods, associated types of structs, and we'll get a brief introduction into traits when we cover the debug trait. If you'd like to read more, you can read chapters 5.2 and 5.3 of the Rust book. So, review from last time. What is a struct? It's short for structure. It's a composite type, meaning it can hold multiple values of other types inside itself. But unlike a tuple, a struct has field names. This is similar to like object classes in languages like Java or Python. So this is how we define a struct. This shall be review. You have field names followed by their types, and you can initialize it or to instantiate it by defining it as such on the right, and the order of the fields does not matter when instantiating. So let's cover this example. We have a rectangle struct that has both a width and height, and we want a function to calculate the area. Obviously, we can just do it like this. We manually call rectangle width times rectangle height. But what if we want to have a nice function for a diagonal or for other like triangles or other rectangles other than this one? So we want to decrease code repetition by making a separate function for this. So here we'll show an example of a function. We have a rectangle area that takes in a rectangle, a reference to a rectangle, and returns the unsigned 32-bit integer which represents the area. So the width times the height, which are both U32s. So here we have the syntax described to call this function. We have the rectangle area, we have a rectangle, and we borrow it. So, is there other syntax we can use for this in a more object-oriented sense? Yes, there is. Methods. They help us organize functions under specific classes, or structs in this case. So up here, this is how you define it with the normal syntax, where you pass in a reference to this rectangle. But here, using the method syntax, where the rectangle is implicitly referenced like this. The way you write a method is by implementing functions for the rectangle using the impl keyword. By using this keyword, along with the class the struct you're implementing functions for, you can define any number of functions that operate on any instance of the rectangle class or struct. Like for example, any rectangle that you instantiate now, you can call .area and it will return the area of this rectangle. Just like before, it still takes a reference to the rectangle, but it's a special thing here where it's self, so it knows the type of rectangle since it's implementing itself. It's syntactic sugar for the exact same thing pretty much. So self can either take a reference like this, it can take a mutable reference, only one at a time though, or it can take ownership and move this rectangle. So let's say you don't want to have the rectangle after, you don't have a borrow here, and you just take ownership into the function. So let's cover a mutable reference. Just like this, we can modify the function, or we can modify the current rectangle that the function's operating on, just like this. But we can only borrow it once, so you cannot borrow it again mutably within here. Here's an example that takes ownership. So it takes a rectangle, then returns a separate rectangle of width and height 42. See how we use the self keyword again, except this time in capitals, to represent it's the type and not just an instance of this type. So there's another example where it moves it into the function, but it does nothing. So the rectangle you called disappear on can no longer be accessed after this. It goes out of scope and it's deleted. So what are associated functions? They're essentially Rust's take on methods. They're any function you define in an impl, like here, disappears an associated method of rectangle since you defined it within here. You can also write functions that don't take in the self keyword, like say you don't have anything here. These aren't methods, but they're tied to the type as such, so you can call rectangle dot some function. Or not dot, but it's colon colon. This is helpful for constructors. Like here, you call colon colon new with an associated function to the type rectangle. Just like this, you can define a new rectangle outside of the access of the potentially private struct rectangle. So here's another example. You have rectangle here, and you have a function description which doesn't take in a rectangle. So just like string, from is actually an associated string, or associated function of string, just like description is an associated function of rectangle. So rectangle description has nothing to do with any instance in particular. It's kind of like a static function, except it doesn't operate on anything right now, at least. So, what's the difference between a method and a non-method? Right here, associated function. It's associated to the type and not the instance itself. So here, a method, it operates on a specific rectangle. It matters which rectangle you call it on. While this operates on the struct itself. So it wouldn't be valid to use it on an instance of the struct, rather on the type of the struct itself. So here's one example of a trait. A trait in Rust is a way of programming where you can have multiple structs implement the same types of behavior. Then you can only accept specific structs based on their behavior. Like here, using this derive compiler macro, it tells the compiler to like essentially assume what it thinks the debug trait should be for this. The debug trait is essentially pretty printing for more complex structs, for lists, vectors, or vectors are lists, or arrays. And just like this, it's automatically inferred for the rectangle type. For example, this is how you call the debug trait for any object here. And you can do it like this. It will print normally. This is the same behavior for vectors and arrays. Then here is more fancy behavior. You can do it. You can have new lines. Yeah. So overall, structs, composite types with named fields, unlike tuples, they have associated functions that aren't specifically tied to an instance. They have methods which are tied to instances, so they can take in either a reference, a mutable reference, or they can move the instance itself. And they're not methods, which, the not methods don't take in an instance and use the type of rectangle instead of the instance itself. Then, to easily pretty print stuff, you can use the debug trait. So tell the compiler to derive what it'll look like to debug on your system. Okay, so some announcements. Homework 7 is released today. It is due next Tuesday. MP1 was released last week, and it is due next week on Wednesday. And MP2 should be released soon. Okay, thank you for watching.